Hello everyone and welcome to GitOps Summit 2021. My name is Ricardo Castro and I'm a Senior Site Reliability Engineer at Farfetch. Today we're going to talk a little bit about GitOps. So if you don't know anything about GitOps and you want a gentle introduction to the topic, you've come to the right place. So what will we be covering today is GitOps in general. We'll see a little bit about what GitOps is and what can GitOps do for us. We'll focus a little bit on GitOps in the realm of continuous delivery software agents in the Kubernetes world. We will then see a small demo of a GitOps software agent, and we will end with a few extras about GitOps and some of commonly asked questions. So let us first start with a small story. So it's a beautiful day, the sun is shining, and our life is good. And I decide that I need to do a change. That change is a little bit tricky, so as usual, a colleague from my team decides to take a look. We submit a PR and we just to check that everything looks okay. So he reviews the change, says it looks good, so we go through with that change. So we click enter and disaster happens. So we have a Kubernetes cluster that suddenly is gone and chaos ensues. So this is now at this moment. So a Kubernetes cluster went bust. So we have applications down. We have a lot of stuff that is down. So now we need to recover from this. So, but how do we do this? Thankfully, we are using infrastructure as code, so there's not that much of a trouble to bring the cluster back up. Hopefully, that's how it happens. Cool, the cluster is up. So now we need to figure out what needs to be relaunched. So we have a bunch of applications running there, both synchronous applications, asynchronous applications, maybe some database. So we need to figure out what needs to come online. So my colleague Joe is very happy because we have a pipeline for everything. So we just need to trigger those pipelines. But actually, we need to figure what pipelines actually need to be triggered. So we start figuring that out and we start activating pipelines. Suddenly, in the middle of this process, I realized that one pipeline was deactivated, but I have no idea why. So we need to ask the team why that pipeline was deactivated. Also, we realized that one of the pipelines actually ran, but the application is not working. We have no idea. And my colleague just remembers that there were some manual changes there from a specific team. So our headache continues. So although we have infrastructure as code, although we have pipelines for almost everything, there are still things that were not actually recorded in code so that everything was working perfectly. So how can we improve on this? So GitOps is an attempt of a solution for these kinds of situations and is built on four basic principles. One of the first principles is the idea that the entire system is described declarative. So Kubernetes is just an example of many modern cloud native solutions that are declarative, and we can treat everything as code. Declarative means that the configuration is guaranteed by a set of facts instead of instructions. So what we are meaning by this is that instead of us saying that we want launch me a server, put this file at this location, start this application, we actually declare what we want. We declare that we want a server with this application running and a file at this location. This allows us to version everything in Git and use Git as the single source of truth. So our applications can easily be deployed and roll back from, for example, from a Kubernetes cluster. And even more importantly, when disaster strikes, our cluster infrastructure can also be dependably and quickly reproduced. Another important point is the fact that the canonical desired system state is version in Git. This means that with this declaration of our system version in a version control system, it can serve as the canonical source of truth. And we have a single place from which everything is derived and driven. This makes rollbacks trivial. We can use a git revert or a rollback to a previous application state. Also, with Git excellent security guarantees, we can also use SSH key to sign commits and enforce stronger security guarantees about the authorship and provenance of our code. Another important point is the fact that approved changes can be automatically applied to the system. So once we have everything in Git, the next step is to apply those changes in an automatic fashion. This means that we don't need cluster credentials to make changes to our system. And with GitOps, there is a separate environment of which the state lives outside. This allows us to separate what we do to what actually is being done. And the last step, the last important point is that software agents are there to ensure correctness and alert us on divergence. Again, once the state of our system is declared under version control, software agents can inform us whenever there's some mismatch between what is in Git and what is on the cluster. Those agents can not only alert, but actually go the extra step or actually making everything convergent. So what, on a daily basis, what can GitOps do for us? So these are some of the benefits that GitOps can bring to the table on a day-to-day basis. So we can gain a little bit of increased productivity. So continuous deployment and automation with an integrated feedback loopback means that our mean time to deployment recover. We can estimate that we can ship code several times faster every day and increase our output times. We also gain enhanced developer experience. So we can push code and not containers. That being said, developers can use familiar tools like Git to manage updates and features to Kubernetes more rapidly without having to know the internals of Kubernetes itself. And newly onboard developers can quickly get up to speed and be productive within days instead of months. We also gain improved stability because now we are using Git workflows to manage our clusters, and we automatically gain a convenient audit log for all of the changes are already outside of Kubernetes. That audit trail will tell us who did what and when, and it can be used for to meet compliance requirements like SOC 2 or PCI compliance. We also gain higher reliability. So now we have can use Git to revert and rollback or even fork, and we gain stable and reproducible rollbacks. So the entire system is described in Git, and it's also the single source of truth from which we can recover after a meltdown. We also gain consistency and standardization because GitOps provides one model for making infrastructure changes for apps, infrastructures, or even Kubernetes itself. And we have a consistent end-to-end workflow across the entire organization. Not only are continuous integration and continuous deployment pipelines all driven by pull requests, but our operation tasks are also fully reproducible through Git. As we've seen before, we gain stronger security guarantees through Git. Git is backed by strong cryptography, and we can use that to track and manage changes, as well as the ability to sign and prove the authorship of the origin of those changes. And of course, we gain compliance in auditing for free. Since all the changes are tracked and logged in a secure manner, compliance and auditing are a bit more easy. So the use of, after that, the use of comparison tools like kubediff, teradiff, or ansiblediff will allow us to compare a trusted definition of state to what actually is on a cluster and decide on the changes that need to be made. So what are some of the characteristics that GitOps software agents need to be? So they need to be declarative. So they need to be the way that we've described before, declarative instead of imperative. Because GitOps is using Git by the underneath, we're going to be put those declarations in Git. Ideally, they should be automated, so we don't want to actually be applying changes manually. That's error prone and it's not scalable. They of course need to be auditable, so we have now an audit trail of everything that changes outside Kubernetes, but we also need to know how things were working inside a cluster. For our use case, we also aspire for it to be designed for Kubernetes because we are going to be deploying applications to Kubernetes. Also very important is the fact that it needs to have out-of-the-box integrations. This means that we don't want to actually be implementing everything from scratch, so it needs to have some out-of-the-box integrations for common usage patterns. But at the same point, we also need it to be a little bit extensible in the sense that we all have some particular use cases on our infrastructures that we actually need to input our own logic. So now we're going to see some examples of some GitOps software agents. So the first example of an agent that we are going to see is Flux. So Flux was made by the company that popularized the GitOps, which is called Weaveworks, and it's a tool for keeping Kubernetes clusters in sync with sources of configuration file in Git repositories. And it means to automate all the deployments into our cluster. So the way that Flux works on a high level, it has a source controller that looks at the definition in Git and decides what it needs to do. So it understands how to work with the Kubernetes API, and it also has support for customize and Helm controllers. And those controllers will be responsible for deploying Helm shards or customizations. Those controls will also keep everything in sync if any change is done in Git. Another interesting project is the ArgoCD, and it is a declarative GitOps continuous delivery tool for Kubernetes. On a high level, it works in a similar fashion to Flux, so it knows how to look into a definition in Git, and it knows how to interact with the Kubernetes cluster. Of course, it knows how to work with the Kubernetes API, but it also has support for Helm, Customize, and other kinds of tools. In the middle of this process of GitOps growing in the community, both the Argo team and the Flux team realized that there was a lot of common ground between the two projects, and they created a project that now lives on GitHub, which is called Argo Flux. And the idea is to build a common GitOps engine that they can both use, and then they can build on top of that common engine some differentiation tools. So it's actually worth taking a look. And last but not least, we have Jenkins X. So Jenkins has gotten a bad rap in the last few years. So this is an attempt from the Jenkins team to actually embrace cloud native from the ground up. And they decided to build the Jenkins X on top of GitOps. So again, on a high level, it works on a similar way. It knows how to look into a Git repository and understand a definition and actually know how to interact with the Kubernetes clusters to make that deploy. So on a high level, how would a GitOps pipeline work like? So we do some changes, we push those changes to Git, we will follow our normal patterns, and probably a code review. When everything is merged, we build a container. We can then have a tool that can be implemented in many different ways that is looking at a container registry and realizes that there is a new version of the software to be deployed. That config updater can push a change to a Git repository, can be the same, can be another, it depends on configuration, and say, okay, so here's a new version of the software that needs to be deployed. And then a deploy operator that will live inside the cluster will actually see that change and apply that change into the cluster. So now we are going to see an example of one of these CD software agents in practice. The example that we are going to see is Flux, and we are going to see a demo of Flux deploying an application to a local Kubernetes cluster that we are going to use. We're going to see the examples of the files that Flux knows how to understand, and we're going to see that it actually deploys the application into a cluster. So we are going to use an example application that I have used a few times in presentations, and it basically we're going to launch a Kubernetes cluster locally that we are going to point to this repository that has some definitions of the Flux knows how to understand. So let's just quickly start by creating the cluster so that we don't lose a lot of time. So we're going to be using K3D to create a two-node cluster to actually deploy our application. So this is just going to take a few seconds. It's creating a bunch of configuration, and in a couple of seconds, it should be up and running and functional. So everything is good. Just updating our Q config. Okay, so now we're good to go. So before we continue and putting Flux to work, we're going to see what Flux is going to see. So we're going to bootstrap Flux using this command, and we are pointing to this specific cluster at this staging cluster. So folder. So what lives inside this definition? So if you look here, we will have a bunch of files that will be deploying this application that we're going to see in a few seconds. So here we have a bunch of files that Flux understands, and this is just an example that shows that Flux can actually send some information to the Git repository and make them persistable. So let's just first look at this file, which is called web app source. And here we are defining a Git repository that Flux will use to fetch some information. We declare it with a name, we declare it with a namespace, and we're just pointing to a Git repository that has some information. This repository is the one that we have here. So what do we have next? We have something here called web app common. So what is web app common? So web app common is a customization. So we'll have the customized controller actually be looking at this and knowing what to do. And we say for it to look at that repository into this folder to understand what it needs to be done. So let's see what it is living inside this folder. So if you go into deploy, web app common, we see that we have a bunch of declarations for a namespace, for RBAC, and service account. So if you see this file, we see that we just have plain old Kubernetes files. Again, if we go back and see other files, we see that we have something called backend, and it's again a customization that also uses this Git repository, also looks at a folder, but here we have an interesting point, which is the fact that it has a depends on, so meaning that Flux will know that we need to actually wait for everything in web app common to be deployed, so to then deploy web app backend. So that let's quickly look at what lives inside this folder. So if we go into backend, we see that we have the common Kubernetes resources. So we have a deployment, a regular normal deployment for a web app. We have a horizontal pod autoscaler and a service. And the same thing for web app frontend. So web app frontend, again, the same thing, looks at the Git repository, looks at a folder that will have definitions of things to be deployed, but now it needs to wait for web app backend. So let's just put all of this in practice. So if we actually boot everything using this command, we're going to see what Flux does. So basically, Flux is bootstrapping, it's connecting to the Git repository, it's actually cloning locally the repository itself, and now it's deploying its own controller. So it's deploying the source controller, and it will then deploy the other controllers that we said for it to actually deploy. So because we didn't specify any requirements, it will deploy the customized controller, the Helm controller, although we in this demo will not be using. So it says that everything should be done. So now Flux is operating on our cluster, and we should be able to actually see what is happening. So let's go back and see. So the first thing that we're going to do is see the customize controller in action, and we'll see that if it has some customizations. So here we can see that the customize operator realized that it has a few things that it needs to apply. So in this particular example, it saw that web app common was to be deployed, and it's already deploying it. It will then go on for web app backend and web app frontend. So if we can see, as we can see here, so web app common has already been deployed, and it's now deploying web app backend. So if we do a watch for the customized controller logs, just to be sure that it is doing something, we can see here that it's doing, he's meeting dependencies, it's seeing if the dependency has already been applied, if the customization has been applied. So here we have some access control of what actually is being done. And again, if we watch for the pods that are coming through, just to be sure that everything is showing up. So here we can see that the web app backend was already deployed, and now the web app frontend is already being deployed. After a few seconds, we can verify that everything should be up and running. So if we test our application, it should be working. So let's quickly do that. So we just port forward to the cluster, and we see that we have the application here. So we're just pinging, just make sure that application is running, and just to be sure that it's actually doing something. We see that it's also exporting metrics. So this was just a quick example of Flux in action, and how we, by having a definition in a Git repository, Flux can understand it and actually deploy something to a cluster without we doing anything. This means that we can launch a cluster, just point Flux to this kind of definition, and automatically know how to reconcile everything. We will now go through a few questions that usually arise when we talk about GitOps. So one of the most common questions is about secrets. So people usually ask, okay, so this is all well and good, but I have everything in Git. How do I deal with secrets that I need to provide to my applications? So there are several ways to approach this. These are just 3 examples of projects and approaches that we can follow. The first one is called sealed secrets, and the idea is that we encrypt a secret, and it will live alongside our code, and then inside the cluster the agent will have a private key that will allow it to actually decrypt that secret and provide it to the application. SOPs is a project from Mozilla that follows a similar pattern. There's a public key that which we will use to encrypt secrets and put it in Git, and then an agent inside the cursor will actually decrypt and make that available to the application. Another solution is to use the Vault agent sidecar injector that will actually connect to a Vault cluster, fetch the secrets, and provide the secrets to the application either via a file on the file system or through environment variables. Another common question that usually arises about GitOps and versus IAC. So one of the main differences between IAC and GitOps is the use of immutable containers as deployable artifacts that can be converged on a suitable orchestration tool, for example, Kubernetes. So the idea here is that the concept of immutable containers. Of course, we can extrapolate this, and GitOps can be used for everything and include IAC, and we can achieve the same thing. So the idea is that while infrastructure as code tools provide the way to manage infrastructure, they don't manage the entire cloud. And following a GitOps approach, we can include IAC inside GitOps and manage the entire cloud native stack. Another common question that actually comes is usually the between push and pull. So the idea many times is that we have a pipeline and we would push a change into a cluster, for example. And with GitOps, we're flipping that, and we're advocating for a pull. So the idea here is for the cluster itself to look at the definition, it actually updates itself. In many cases, this becomes more secure because we don't actually need to open a cluster to the outside world. We just need to tell the cluster where it needs to find its information. And in some use cases, it can actually be beneficial. So imagine that you have a multi-cloud application, for example, between Amazon, Azure, and Google, and it's deployed on multiple regions. We don't need to actually have in one region, for example, a CD server that pushes changes in all those regions, because the clusters themselves can actually connect to a Git repository and know and understand what they need to do. And this was it from my part. I hope this was an interesting presentation of what GitOps is, what it can bring to the table. Of course, GitOps, it's not a silver bullet. It's just an approach and another tool to have in our belt that can actually help us manage and, for example, help us achieve some requirement compliance. So thank you very much for attending the talk. And if you have any questions, don't hesitate to contact me and send the questions my way. Thank you.